This video is on literal equations, which is solving one equation for a variable specified in terms of other variables. And it is definitely needed in calculus for various topics. The best way to do it is just to do several examples to practice because you have all kinds of types of equations that you might need to deal with. So we're just going to jump right in and look at our first example. So this is an example where you have fractions. And so my favorite way to deal with equations that have fractions is to eliminate them. So we're going to multiply both sides by the least common denominator, which would be A times B times C. And so we're going to multiply each term. So when we do that, that is going to give us a BCX plus ACY and then ABZ. And on the right side, we're going to have ABC. Now, always it's important to look for the variable that you're trying to solve for, which in this case is A. And A is actually present in three of the terms. So when this happens, you want to group all of those terms together on one side so that you can then factor the A. So we're going to put the BCX term over here and we'll move the ABC term over here. So doing so, we've got ACY plus ABZ. We're going to subtract over the ABC, and then we're also going to subtract over the BCX. So it looks like this. Now, those three terms on the left all contain an A, right? So we have the A, and that is what we're trying to solve for. So we're going to factor out an A, and that leaves us with CY plus BZ minus BC, and that's equal to minus BCX. So the last step now is to divide everything by what's in the parentheses, and you will have solved for A. So your final answer would look like that, CYBZ minus BC in the denominator. And then also just make sure that you're aware that sometimes if there's a negative up here, it's common to rewrite the whole fraction and you can arrange the terms, but we'll do that in a later problem. So for right now, we'll just say this would be our final answer. So let's look at another example. This one also has us solving for A, and we can also see that A is in multiple places. So one way to do it is you could distribute the two, but I think the quicker way is just to go ahead and divide both sides by that 2. So we're going to have 1/2 V, and then now we just have everything on the right side that was inside the parentheses. And the strategy is the same. You want to group your A terms together. So these want to be on the same side, and we want to subtract the BC over here. So you have 1/2 V minus BC, and then that's going to be equal to AB plus CA. So we'll do the same thing, factor out the A. We could flip the whole equation, if you will. We can just do it at the end, whichever, if we like to have the convention of having the A on the left, right? So we're going to divide both sides by B plus C. So we will end up with A, and then we're going to take the 1/2 V minus BC, divide it by B plus C. So we'll leave it like so. Okay, so this one is also complete. Next example, number 3, solve for R, and It really just says the positive R, right? R is greater than 0. This one is interesting because R is squared. So you have a squared term, but then you also have another R here. So basically we have a quadratic. So we're going to use the quadratic formula. We're going to rewrite this in what you would call the standard quadratic form. So I'm going to subtract the A over to this side so that we get a 0. And then we're going to put our squared term first, then our linear term, our constant, and then we have the 0. So here you can see that if we're looking at the A, B, and C that are generally in the quadratic formula, right? So if we write down the format that we're used to looking at, the A in this formula would really be just the 2 pi. The B here would be the 2 pi h, and C would actually be minus the capital A. So we're going to use those values, substitute into the quadratic formula. Now, it does say just to use the positive R, so we actually won't need the minus one here. So we just are going to do the minus B plus. So we can go ahead and substitute just in the plus, not the plus minus. So we'll say here that R is going to be equal to the opposite of 2 pi h plus, and then underneath our radical, we're going to square our B term, which is 2 pi h squared. And we're going to subtract 4 times the 2 pi times the minus A, and everything is divided by 2 times A, which is 2 pi. So we need to clean it up, right? So you want to simplify it, because if you are going to do something with it in calculus, which is usually what you're going to do, you're doing kind of manipulating all these formulas to do something. So you want to simplify it. So we will keep going. The inside, we could square those out if we want. So that's going to be a 4 pi squared h squared, and that's going to be a plus 8 A, or we could say the pi first just to keep everything kind of in the same order. We have a plus 8 A pi, and then divided by 4 pi on the bottom. We can factor out a 4 underneath the radical. We could actually factor out a 4 pi. Let's go ahead and just do that. So that leaves you with pi h squared plus 2a. And then we still have all of this divided by the 4 pi. And then now that 4 can come out of the radical as a 2. But everything else needs to stay where it's at. So let's bring that out. And so you have a pi times a pi h squared plus 2a. And then everything is divided by 4 pi. And then every one of these terms is also divisible by 2. So we can write our final simplified answer like this. We'll divide everything by 2. You have a minus pi h, plus you're going to have the square root of pi times pi h squared plus 2 times a. And then all of this will be, just one of those 2's will be simplified. So you'll have a 2 pi. So we can leave it like this in its simplified form. So that one involved the quadratic formula. Sometimes that happens. All right, let's go over here to number 4. This one should be a little more straightforward. So solve for P. Both of these terms have a p, so let's factor one of those out. And then we're left with 1 plus n times r. So all we need to do is divide by 1 plus n times r. So p is going to be a over 1 plus n times r. And that's it for number 4. We'll go down here to number 5. This one says solve for d. So you want to gather up your d terms, just like we've been doing before, right? So that's a d term and that's a d term. So we're going to put this one over here by subtracting, and we're going to put this one on this side also by subtracting. So we can do that in one step. You'll have minus 2yd minus xd on the left, and then we will subtract over the 2x. So we'll have a y minus 2x. And we do the same technique. We group them together so we can then factor out the d. So now you have minus 2y minus x, and then y minus 2x. So divide both sides by the minus 2y minus x. And then minus 2y minus x. And once again, we can leave it like this. It is also common to factor a -1 out and rewrite them. You could rewrite this. So you just need to be familiar with in case you see it different ways. So if I factored out a negative, that's going to make the minus 2x positive, and it's going to make the positive y negative. And if I factor out a negative here, both of those terms will become positive. So another way to actually write the same answer could look like this. 2x minus y over 2y plus x. And that's important, especially if you're on a test and maybe it's multiple choice. Or if you want to, need to rearrange things to make it look more simplified, it's important to see that these are the same thing. So you definitely want to become proficient with manipulating your algebra around. And then finally, number 6, this is our last one. We have a fraction, so we're going to do the same thing that we did in the first problem, and we're going to multiply by the least common denominator, which would be a 4 pi. And of course, you want to do that on both sides of your equation. So we end up with a simpler equation. All right, we have a 2x, and then we're going to have a 2 pi, but be careful, it has to be multiplied by the 1 minus x. And then, of course, the right side is just going to remain 0. Now, we're solving this for x. So let's go ahead and distribute the 2 pi. So that way we can see our x terms. Okay, we have 2 of the x terms. So we don't need the 2 pi, so we'll subtract it to the other side. So 2x minus 2 pi x, and then we're going to subtract this 2 pi over here. So factor out your x, and then 2 minus 2 pi. All right, and then divide by 2 minus 2 pi. So solving this one for x gives you minus 2 pi over 2 minus 2 pi. And just like we said in the last problem, you could divide all of those terms by a -1. And if you do that, it would actually look like this. So this is probably a more popular way to write the final answer. Okay, so there's 6 examples that would all be helpful for you in a calculus class to practice 6 different styles. So feel free to, pause the video, rework them on your own, make sure that you are proficient in that, and that would be great practice. See you in the next video.